Example number 6. Solve integral of e to the 3x plus e to the 3x dx. Solution. Integral of e to the 3x times e to the 3x dx. What we did here, we see that in our given function the power has two terms and they have addition, and that's why we can change it into two terms, the product of two terms. Now integral of e to the 3x times e to the 3x dx. Let's suppose e to the 3x equals to u. Take derivative here, du over dx equals to 3 times e to the 3x. Separate the x variable. We have now du over 3 equals to e to the 3x dx. Just replace e to the 3x by u here. And e to the 3x dx by du over 3. Pull out the 3 outside of the integration. 1 over 3 times integral of e to the u du. Take the integration of e to the u with respect to u. When you integrate this term, you will get 1 over 3 times e to the u. Integral of e to the u is e to the u plus arbitrary constant. Remember, we applied this formula here. The value of x is u here. Now substitute back the value of u, which was e to the 3x. Solve integral of 1 plus e to the minus x over 1 minus e to the minus x dx. Solution. Let e to the minus x equals to u. Multiplied both sides by natural log x. We have natural log u, natural log e to the minus x. According to the logarithmic rule, natural log will cancel with the base e. We have now minus x only. Differentiate both sides with respect to u. For the left side, we don't have any issue, we have u variable. But for the right side, we have x, there is no u variable. Derivative of natural log u is 1 over u. And derivative of minus x with respect to u is d over du times minus x. You just simply put the symbol of derivative, which is d over du times minus x. Separate the variable x and u. At the left hand side we have u term, which is minus 1 over u times du equals to dx. Just replace e to the minus x by u here and dx by minus 1 over u du. Now why we did this extra calculation? Because ultimately we need everything in the u term. We don't need x. Minus integral of 1 plus u or 1 minus u times 1 over u du. When you look here, it is not easy to simply integrate. We apply another method which is called partial fraction. Here we use the partial fraction. So for the partial fraction, just make two terms. For the u, we make a over u. For 1 minus u, make b over 1 minus u. And one thing you have to remember, whenever you do the partial fraction, you need to look to the denominator. So at the denominator we have product of two terms, u times 1 minus u, and therefore we made separate terms. Now we're gonna find the value of a and b. We can say that this term equals to this term here. We took common LCM of the right hand side, which equals to a times 1 minus u plus bu over u times 1 minus u. These two terms are similar at both sides, u times 1 minus u. They will cancel each other and we're left with only 1 plus u equals to a times 1 minus u plus bu. Now if you put the value of u equals to 0, just put the value of u equals to 0 in the above expression and you will get a equals to 1. Again, put the value of u equals to 1 in the above expression you will get the value of b, which is 2. Here we got the value of a and b. Just substitute these values for a. Our a is 1 and our b is 2. When you look here, it is easy to integrate on our u. But it is not easy to integrate 2 over 1 minus u. Let's solve this term here in extra calculation. Suppose 1 minus u equals to t. It's the third variable, t. And take derivative on both sides. We have dt over du equals to minus 1. Pull out du here to separate the terms. Now we have du equals to minus dt. Just replace 1 minus u by t and du by minus dt. Pull out 2 here at outside. Minus into minus will be plus. So we can write 2 times integral of 1 over t dt. Take its integration. We have now 2 natural log t. Substitute back the value of t, which was 1 minus u. And here is the final answer for the right term. We just calculated this for integral of 2 over 1 minus u du plus arbitrary constant. So here is the final answer for the given function.